Here's the key to test 5. We have a space vehicle. It's in a circular orbit, a radius r sub a, and I marked that wrong in the drawing, but this is r sub a right here, okay? And then around the moon. To transfer to a smaller orbit, a radius r sub b, the vehicle must be first placed into elliptical path AB by reducing the speed by delta v sub a as it passes through A. Knowing that the mass of the moon is cap m, determine in the A part, we'll find the speed of the vehicle as it approaches B in the elliptical path. And then the B part is how much do we have to reduce the speed at B to insert it into a smaller circular orbit of radius r sub b. Then this is r sub b right here. All right, so we're given r sub a, r sub b, capital M, capital G, and delta v sub a. We know that the velocity for a circular orbit is given to us in our list of equations that we can use on this test, and so it's gm over r sub a right there. So v sub a prime, which is the velocity after you've reduced the speed right here to be able to put it into that elliptical path that takes you over to B. So the velocity a prime is going to be equal to the velocity of A plus the change in the velocity of A, okay? So velocity of A is square root of gm over r sub a plus the delta v sub a. We also know from the conservation of angular momentum, and this is going to be conservation of the little h, so the m's are not appearing in here, but RA times VA prime has got to be equal to RB times the velocity coming into B along this elliptical path, which we call it B. Remember, the prime is to indicate after a change has been made at a point on the orbits. So we solve for V sub B out of here, and we get RA VA prime over R sub B. So there's the RA over R sub B right there, and VA prime is this right here. So we pull it down, and that's the answer for the velocity of B. Now, in the B part, we're asked to find out how much do we reduce it down again. Well, the change in velocity at B is going to be V sub B prime minus V sub B. Well, delta v sub b then is v sub b prime. V sub b prime is square root of gm over r sub b. And then minus v sub b is that term right there. So that completes the problem.